All right, good morning. Good morning, and welcome to the latest installment of Mazzetti's Bending the Climate Curve Learning Series. I'm Christina Vernon-Sanborn, Principal and Sustainability Practice Leader here at Mazzetti, an employee-owned benefit corporation where bending the climate curve is our mission. This morning, we will be talking about kitchens. I'm particularly excited about this session. We're going to explore Power Shift, the economics of electrified kitchens. Chef Chris Galarza will talk about the economic, environmental, and operational advantages of transitioning from combustion gas-powered commercial kitchens to fully electrified induction-based systems. So Chris is a pioneering force in the culinary world. Renowned for his work in sustainability, education, and innovation in kitchen design, he's the founder of Forward Dining Solutions and a co-founder of EcoChef, where he leads efforts to decarbonize commercial kitchens and champion the green industrial revolution within food service. In 2024, he became the first chef in history to achieve the Certified Executive Chef designation in an all-electric kitchen, proving that world-class cuisine can thrive without fossil fuels. Through EcoChef, Chef Galarza and his partners are developing professional accreditations and industry standards to help chefs, designers, and institutions embrace sustainable practices without sacrificing quality or performance. His work continues to inspire a new generation of culinary leaders dedicated to building healthier, more efficient, and equitable food systems worldwide. Today, we're going to talk about these four learning objectives, and I hope that you're as excited as I am to learn about some of the economics behind electrifying kitchens, understanding the differences in performance between electric and gas, how we can think about thermal comfort strategies differently, and think about how the health and safety of the kitchen workforce are affected by this clean transition. And throughout the presentation, he'll be sharing examples from a real-world case study that I think you'll find really illuminating. So before we get started, a bit of housekeeping. Today's event has been submitted for one AIA HSW CEU. If the program is approved, we'll submit your attendance. If you didn't provide your AIA number when registering, please send it to info@mazzetti.com. We'll hold questions until after today's speaker has made his presentation, but you're encouraged to ask your questions at any time, whenever they occur to you, via the Q&A function of the webinar. Today's session is being recorded, and a recording will be shared along with a copy of the slides to all attendees, as well as a recording posted on our website. So with that, I'm going to turn it over to Chris to share his story.
Thank you so much, Christina. Killer intro. So I'm going to go ahead and skip past the first slide because we don't need to hear any more about me. Let's just get right into kitchens. Let me make sure that this is working.
Yep.
All right. So, before we dive into kitchen specifically, I kind of want to set the stage for the policies that have been enacted over the last 5 or 6 years, that started this trend in this conversation nationally on electrification. And for me, even though I started working in electric kitchens far before this, it really started when Berkeley passed their first all-electric building ordinance back in 2019, before times. And that was specifically for new construction. It kind of caused a big hoopla. People started having, being more aware of decarbonization as a strategy, something that can be influenced by policy. After that, President Biden asked OSHA to look into the indoor spaces as the world gets hotter, so are indoor spaces. So how can we combat heat exhaustion, heat illness? So OSHA started working on that. Then Energy Star started saying, like, gas isn't that efficient, so we won't be recommending it for our most efficient list. Then Ithaca became the first city to pass 100% decarbonization of their buildings. Not just new, it's no longer just new construction, it's all buildings. Not to be outdone, the state and the city of New York as well started moving towards electrification and decarbonization. 2024, Cal OSHA had passed the country's first permanent indoor heat illness prevention standard, meaning that the indoor spaces, depending on the relative humidity, can't exceed 82 to 87 degrees Fahrenheit. And if for anybody who's been in a kitchen, you know that that's pretty pretty impossible with the way things are. Uh, Last year, New York passed a $5 billion plan to begin their electrification and decarbonization work that's set to begin last month. So all of that, plus some of the things that didn't include there, led to where we are now, where 11 states, including Washington, D.C., have passed electrification ordinances. That's across 131 local jurisdictions, affecting about 37 million Americans, so roughly 10% of the population. Potential healthcare savings right around $39 billion, and for homeowners, reducing carbon emissions by about 56% over the next 10 years. Now, you might be looking at that map and saying, it's not very impressive, right? A lot of a lot of open space there. Only a few states we're talking about here. But it's important to note where the gas stoves are. And when you lay that over this map, you start to see that that's where all the gas stoves are, right? 70% of California cooks on gas. New York, 69%. Matter of fact, most red states are all electric and have been for a very long time. They just have the infrastructure built that way. So they're ahead of the game. And matter of fact, North Carolina and Tennessee lead the country with 90% and 89% of homes being all electric. So this is begins to kind of paint the picture that like it's no longer an if, but rather a when this is going to be happening. So some folks might be thinking this is just a trend, and maybe kind of. Yes, you're right. Because in 2025, the ACF, which for those of you who don't know, is the American Culinary Federation, essentially the governing body of chefs, put sustainability and kitchen electrification as part of their top 10 trends for last year. So chefs are paying attention, and chefs are no longer as hostile to the idea because we started having conversations with them and started kind of painting the picture for what this is going to mean for chefs. And with all that foundation laid, let's talk about electrification. So, what is induction cooking, right? There's a lot of different technologies in kitchens. We're gonna focus primarily on induction. We'll touch on other stuff here later, but this is the primary thing that people find most controversial. Most people don't care about how their water is heated or how their space is tempered, but they really care about how they cook. So first and foremost, obviously not talking about gas, but when we talk about electric, people often think this, or rather, here we are, this, electric coils, right? I call them grandma's coils. They're slow, not very efficient. Contrary to popular belief, this is more of a fire hazard than gas. And people often confuse this with induction. Glass top, but it glows red. It's essentially grandma's coils 2.0. Uh, Although technically a little bit more efficient than gas, it's also slow, not as responsive, a pain to clean. I personally wouldn't want this in my kitchen. So what we're talking about is induction cooking, which is a quicker way of cooking, a way of cooking that uses electromagnetic currents to heat your vessels. And the way it works is that we have this copper coil that's sitting underneath this glass top. And as you send electrical impulses through, and it's going around and around that copper coil, we're creating what's called an eddy current or an oscillating magnetic wave that excites the ferrous molecules in the pan at such a high rate of speed that creates molecular friction and thus heats up the pan. And it does this very, very quickly. And if you want to visualize this, go into your kitchen, turn on the microwave, and you'll see that similar principles are happening. We're sending these waves that are exciting the water molecules, that's creating the molecular friction that's heating up the food from the inside out. We're just doing that with magnets. So there are some pros and cons, and I think if we're going to have an honest conversation, we got to touch on both. So pros, because I like to be more positive, uh, very high efficient. We're talking 90+% efficiency, and that's a true efficiency versus the 35% we get with gas. And what I mean by that is that when you put a pan on an induction range, you are essentially closing the circuit so energy can flow freely, which is how that energy gets into the pan and the pan thus gets hot. When you remove that pan, you're breaking the circuit so there's nothing flowing. So it's essentially not using energy when you're not when the pan's not on it. The 35% with gas, it's assuming that the pan is in constant contact with the with the flame. When you remove that pan and the flame's still going, there's a drop of efficiency. So in the hands of a chef, we go from 35% efficient in the lab to 10 to 20%, which means for every dollar we're spending on gas, only 10 or 20 cents of that is actually reaching our food. So induction heats very, very quickly. There's a precise temperature adjustment. We can set things to the degree if we so choose. There's a reduction in idling equipment. There's no combustion, which means no carbon monoxide, which we'll touch on later. It's a dramatic improvement of thermal comfort, which we'll also touch on in a little bit. Uh, One of the things that isn't touched on enough is that it's going to extend the life of your pots and pans. Fire is a very violent way of heating up metal, which is why in the kitchen we're replacing pans every year or two because they get warped. So again, if you ever work in a kitchen, you have the saute pans that just won't sit flat. That's why. So these pans will last you a lot longer, which means you're securing your investment. But there are some drawbacks, right? The initial cost may be a barrier for some. Compatible cookware is something people are afraid of. And if you're used to buying cheap aluminum or all copper, yeah, it's not going to work. But most manufacturers want to sell one product to all people. So modern stainless steel pans have a high enough ferrous material in there, so it will work with induction. Uh, if you're used to cooking with cast iron, it works beautifully with induction. And there's also something to be said about whether or not you have enough power in your space, which is something that you lovely folks will be able to assist with. Um, but what solutions exist in kitchens? I mean, quite honestly, there's nothing in a gas kitchen that doesn't have an electric alternative. That includes ovens, griddles, fryers, tilt skillets, ranges. There's nothing that doesn't have an electric alternative. And that includes ethnic cuisine, right? So tandoor ovens and wok ovens. We're going to touch on wok specifically. I believe these are ways that we can refine our traditional ways of cooking. I myself am Latin 4 generations ago, or rather Brazilian 4 generations ago. My great grandfather left his tribe in the Amazon rainforest. Hopefully, one day I'm going to be inheriting recipes from a tribe. I have no idea what their names are, but I know I'll be able to recreate those dishes. And why is that? Because cooking is about fundamentals and techniques. Doesn't matter if you're cooking on a camp stove, a campfire, a range, a griddle. A saute is a saute, a braise is a braise. These things don't change based on your fuel source. The conversation we're having here is how do we get a piece of metal hot, and then what we do with it is up to us. So this 12 kilowatt induction wok, and that's important. Please remember that. Uh, Uses significantly less water. A gas wok, around 100,000 BTUs, will use about 250,000 gallons of water per year per wok. So if you have a restaurant with 4 woks before you even wash your hands, you're in the hole for 1 million gallons of water that year. So this goes to show that there's a lot of waste there beyond just the gas. And that's kind of where I come in, right? So my thinking as a chef has always been food cost. How do we reduce the amount of food we're wasting, which is great. But what I teach chefs and teach people is to take one more step back. How much water is going down the drain? How much energy are we using? How often is your refrigeration, your AC going to be cycling on and off? All that's important. So when we move to wok comparisons, when we move to woks, we're talking about 100,000 BTU gas range, and at 19% efficient, you're cooking about 124 pounds of food per hour. That's a lot of food. It's also a big wok. Now, if we look at this 5kW countertop version, much, much smaller, at 91% efficiency, we're cooking 117 pounds of food per hour. You know, a lot more energy in, and even though it's a smaller vessel, we're cooking almost as much food. So, which means now we can redesign this kitchen to be a little smaller, a little sleeker, be able to produce as much, if not more food than their quote unquote traditional counterparts. So, let's look at these gas ranges. These are the things that I would say are the most controversial. People are really worried about changing because we predominantly use these 6 burner ranges. So if we were to give this gas range the best possible chance of success here, we're going to call it a 50% efficient gas range. I haven't seen one, but maybe it exists. That gas range will be able to cook 38.6 pounds of food per hour. Now, if you've never cleaned a range before, I'm happy to walk you through it. When we break down for the end of the night, first thing we do is we grab our sanitizer water with a scrubby, and we kind of scrub the grates. Just one, to begin cooling them down, but also to kind of dislodge any loose food particles that may have fallen on. Then we grab those grates, walk into the dishwashing station where we have presumably hot water and degreaser there ready to go. We'll deposit them there, come back, We'll turn off the pilot lights. We'll pull each burner out. We'll take a toothpick, go to every single hole, make sure that there's nothing obstructing the flow of gas, walk all those back over to the dish pit, which, by the way, the dish room is never right next to the cooking line. So it's a bit of a travel. And then underneath here is what's called a drip tray, right? From there, we pull that out, and normally a foil liner, that's where all the liquid and the food and the carbon would have fallen there. We pull that out, we dump it into the trash can, we degrease that, we sanitize that, we dry that, we put a new foil liner back on, put the drip tray back in, go back to the sink, but then hopefully everything's kind of softened up. We can scrub as best we can all the carbon and food and soot off of that, run it to the dishwasher, dry it off. We're good. Bring it all the way back, reapply everything, reinstall everything. Then we'll turn on all the pilot lights. The whole time this is going on, pilot lights are off. Gas is just pumping into the space. Throughout that whole process, roughly about 30 minutes, right? All the while, I've seen and I've experienced burns, fires happen, these things happen. Um, Conversely, with induction, we're talking 90% efficient, 70.9 pounds food per hour. So now we're instantly nearly doubling the amount of food we can produce. It's a lot easier to clean. So 30 minutes for range, about 90 seconds with hot soapy water, and you're done. So now you went from 30 minutes of labor with chemicals, with gallons and gallons of water, if you account for the water in the sink. And then with an induction range, we're talking about enough water that goes, well, a bucket of water, maybe a quart of water. You wipe that down, you dry that off, you're done. So now you have more time for production, less time for cleanup. You see how this is going to benefit your clients. A lot easier to clean and safer to use as well. So I've spilled cream here, nothing burned. You can grab handles, you're not going to burn yourself. It's a lot easier to operate. So what are these efficiency comparisons I talk about? What I talk about is the efficiency is the energy coming into the equipment versus what's actually reaching the food, the end product. So at best, again, a 35% gas range, each burner is getting about 10,000 BTUs to the food. Induction at its worst, it's getting you 14,000. So you can see how we're getting more energy equals more food produced. Again, that 12 kilowatt wok at 87% is getting you 35,000 BTUs to the food. So we actually have two of these installed in Microsoft's global HQ. They don't go past half power. They're feeding thousands of people a day. They don't need it. It's too much power. So it's much, much more powerful than gas, even though a wok, again, has like a jet engine underneath it. So then people say, you know what, but the energy costs. Gas is more expensive, is cheaper than gas is more expensive than electricity. That may be true if you're using them equally, but you're not, right? We've already explained how that's not the case. So then there's some assumptions that were ran by our good friends at the Food Service Technology Center. If you were to operate for 360 days a year for about 15 hours a day, and you were spending about $1 per therm for that gas range versus 17 cents per kilowatt hour, you'd be spending about $1,123 a year to operate that gas range versus 1,114. Now, these numbers were true national averages before the pandemic. Well, now those things change. So earlier last year, I ran the same calculations, found that the national average was $1.42 per therm, and electricity was 13 cents per kilowatt hour. So that means that gas increased 42% and electricity went down. All right. Well, what are those averages now? So now it's going to be about $1,600 a year to operate versus just under $900. These are going to fluctuate no matter where you are. So we just to take it to a step further, that's even more recent. We're working on some calculations for a client, and for the gas baseline was just under 18 kilowatts of power once you convert BTU to kilowatts, which means that with induction, we increased power by about 12%. We were decreasing energy usage once you convert therms into kilowatt by 85%. Energy cost was going down by 46%, and the client was reducing their carbon emissions by 90%. This client pays for carbon offsets and pays for RECs. So it's a significant cost savings for them, and we'll touch on that later. So thermal comfort's a big deal that, again, not discussed enough in kitchens, or at least in the design process. So thermal comfort can really be broken down into three pillars. The first is Mother Nature, i.e., things you can't control, air velocity, temperature, humidity, all these things. Then things that you as the building owner can can control. What's the temperature that you're setting things to? What are the equipment and what's the energy that, the heat that it's radiating? And then what is you, the individual? What can you control? That's your clothing. What are you doing? All that stuff. So ASHRAE did a study where they found the optimal thermal comfort range between 68 and 82 degrees Fahrenheit. Now we know where OSHA got that number from. And they tested about 100 kitchens for about a week in both summer and winter conditions. They found that the only time a kitchen was comfortable is around when they were cleaning or prepping. When you're cooking, you're far outside that zone. And that's bared, that data is bared in reality, right? The New York Times in August 2023, feel free to read the article. It's a really enlightening article. Found that kitchens in New York City was regularly exceeding 130 degrees Fahrenheit. For those of you who don't know, the hottest temperature ever recorded in human civilization was in Death Valley, California at 134. So chefs are not in flip-flops. We're not in t-shirts. We're working in chef coats and pants, and we're working in things that are designed to keep us from catching on fire uh, in conditions on par with the hottest places in the world. And we're doing this for hours, 8, 10, 12, 20 hours. I've once worked a 40-hour shift. No sleep. It sucked. So yeah, we as chefs, we put ourselves through a lot just to feed people. So there's got to be a better way of doing things because this, although it looks cool, is not sustainable. I have known myself, many other chefs, even Anthony Bourdain wrote about it in his book. These kitchens are hot. We, in between rushes, would go to the bathroom, throw up, whatever the case is, and then get back to work. I've known people that have picked up smoking just to go outside and get fresh air, which is what a backwards way of doing things. But it doesn't have to be that way. Kitchens of the future, these kitchens that we have now, they're much more comfortable. I can tell you from experience, I went from the prototypical hot-tempered chef to much more calmer, relaxed, easygoing. My staff, there was less infighting. Our guest satisfaction survey scores went up because people were more comfortable to be around. It was a whole shift that we just can't put into, we can't quantify. It was nuts. Like my mental health was better. My physical health was better. It's a remarkable shift for the people inhabiting the space that I think needs to be talked about more. Human-centered design needs to be part of what we do. And this is the kitchen data from Chatham that we had that we some of these case studies are going to be coming from. So this temperature that we gathered over the course of a week between September, was it 9th through 16th of 2019, showed that, I don't know if you can see it, it never exceeded 74 degrees Fahrenheit. Mind you, we don't have air conditioning in that building. So the outside temperature was anywhere between 85 and 90 degrees Fahrenheit. And it was cooler in my kitchen during production, cleaning, prep, the whole nine for a whole week than it was being outside. That's not normal for a commercial space. So, what are the health considerations of being in this space? Well, when we're cooking with gas, we're releasing things like carbon dioxide, nitrous oxide, benzene, which there are no safe levels of, soot, smoke, formaldehyde, which is used for embalming. But we're going to focus a little bit on carbon monoxide because we all know carbon monoxide. We've all experienced it. We've all known that we have to have the sensors going just to make, because it's called the silent killer. So, for those of you who somehow don't know, carbon monoxide is an odorless and colorless toxin where typical outdoor concentrations are anywhere between 0.03 and 2.5 parts per million. Now, I'm going to stress this. Federal outdoor standards is 9 parts per million. Outdoor. We do not have indoor air quality standards in America. And despite what people may think, there are no regulatory authority, no agency rather has congressional authority uh, to change that. They can't change that even if they wanted to. So, but we know that these spaces are regularly exceeding 200 parts per million. We have studied it. We've been in the space with Stanford and both Stanford and NYU conducting a research study, which will be coming out later this year. Plug, plug, plug. Symptoms of which: nausea, vomiting, headache, lightheadedness. These are things that we experience every day as chefs. It's not uncommon. I hope that it's heat related, but if it is from the equipment, that's a problem. But both are problems. Complications of which are permanent brain damage, cardiac damage, and even death. So it's a very serious thing that we should focus on. Now, I can't spend all day talking about the benefits, so we're just going to summarize it here. Um, when you electrify, you're reducing the need for idling equipment. This is a kitchen at a big university in California where a, an engineer was walking through and he gave me a call. Said, "Hey, chef, they're breaking down for lunch. Why is this grill still on?" And I told him, that grill probably has been on since about 6 that morning. They come in, first thing they do, turn on the equipment because you never know when you need it, and you need to make sure that when you need it, it's hot and ready to go, which means you're just constantly burning energy and never doing anything with it. There's, again, needs to be a better way of doing things. Electrifying reduces your building emissions, which reduces your environmental impact. You operate more efficiently, which saves you on energy and utility costs, saves you on water costs, precision cooking controls, dramatic improvement of thermal comfort, extension of the life of your pots and pans. It's easier to clean, which is saving you on chemical costs. It's faster throughput, so you can cook more, which improves your dollar per labor hour. And more importantly, it improves your indoor air quality. So we spent all this time talking about induction, but there's so much more in this space, right? We're talking R290 refrigeration, which has a global warming potential of less than 1 versus the standard R404A, which has a global warming potential of about 3,400 according to the IPCC report. Microwave combi ovens, next gen combi ovens. I saw 20 pounds of wings be cooked in 7 minutes. It's huge. These things are able to, so combi ovens are, like I cooked a whole cavity of whole turkeys in 45 minutes. The microwave enabled ones cook even faster. Demand control ventilation, ventless cooking. We can now turn any dead space into usable space. Solid state RF ovens. If you guys have never seen radio frequency ovens, they're crazy. There was demonstration reported where there was red snapper frozen in a block of ice. They cooked the snapper before they ever melted the ice. Precision cooking in the hands of a chef would be nuts. Then there's also AI and energy management systems. All that encapsulates to creating a truly more efficient and more profitable hospitality industry. But in order to talk about profits, you got to talk about ROI. That's the big question on people's minds. What is the ROI? I think this is a really good example to show, but I want to stress that on average, we're seeing about the dollar per square foot increasing about 20%. Some may be more, some may be less, depending on what they want to do. But this at the Chatham project at Eden Hall was by far the biggest cost disparity. If we wanted to go with a constant flow hood, it would have cost us about $100,000. This one cost us $300,000. So now we're talking about a 300% increase in cost. Sometimes that it's hard to get your clients to say yes to that because they're looking at it from a short-term perspective. But here's where things kind of diverged for us. We decided to go forward with it. This system had remote monitoring and adjusting, heat recovery. Matter of fact, all the cooking heat was saved and used in the geothermal wells. It had geothermal integration. It worked by having these sensors constantly scan the cooktop, and it would turn on and off based on what it read our needs were. So we were able to track these in real time. At the time of us closing, it was a 94% efficient. So while we were cleaning, instead of the hood systems going on at 100%, we were only using 6% of the energy. We were able to identify errors in real time, track the usage by individual hood. It was pretty remarkable stuff. So the red bar was if we were on a constant flow ventilation. It would have been, again, 100% full blast all day, every day. Huge waste of money considering that. And the blue bar was what we actually needed. Right? Talk about right sizing all the time. This adjusts minute by minute based on what you're going to be doing. So again, $300,000, and look at how much energy we're saving. We were projected to pay off this piece of equipment in 14 months. We paid it off in 9, meaning that we were saving about $100,000 a quarter through energy efficiency. It's pretty substantial. One second, gotta take a sip here. So, economics of hospitality. This is something that people are usually surprised about. they forget how important hospitality is to the economy. So in the United States, travel and tourism is the largest single service export for the United States. It accounts for 22% of the country's services in 2023. Uh, we're about $2.3 trillion to the US economy, or roughly 10%. And around the world, you can see how big we are, right? $714 billion in the Caribbean and Latin America, where their economies largely are driven by hospitality. The United States, we dwarf that. They're projected to grow by about 4%. So we're already larger than the Caribbean. Uh, globally, the economics are pretty remarkable. We're about $11 trillion, again, roughly 10% of the global GDP, and again, 1 in 10 jobs that we employ. So it's pretty remarkable that despite all that, the United States is 20% of all hospitality sales. And despite all that, our profit margins are paltry 4%. Before the pandemic was 7%. For every dollar we're bringing in, we're only keeping about 4 cents of that dollar. So because hospitality is so integral to the global economy and the US economy, this is not a sustainable model. We can't expect these businesses to be barely making it by 4 cents for every dollar brought in. It just doesn't work that way. I don't know anybody that would want to invest in that industry. Yet I can't think of any, if not very many, countries that are successful in their economies without a thriving hospitality market. And we're seeing that also in the hotel industry. Hotel brands, about 80 to 90% of them have a sustainability plan. And why is that? Because they see that the revenue per available room is increased about 12% because of that, especially if their hotels are certified. Which is why you saw a 300% increase in certification between 2015 and 2022. And the Radissons are flying through their sustainability plan. So it's important. Why is that? 75% roughly of travelers prefer to choose a more eco-friendly option, right? Uh, because of that, they're willing to pay a little bit more for those rooms because they want to support brands and businesses that share their values. It's a big deal, right? And sustainability is driving profitability, which is reducing waste, lowering energy costs, and performing. These businesses are performing better. It's not just ethical; it's strategic. And the top 100 most successful companies in the world, most sustainable companies in the world, sorry, outperform the S&P 500 year over year. So going back to some other data that we've done for clients, we ran some calculations. The whole space, excuse me, the whole kitchen that we modeled for them had an energy consumption reduction of about 80%. Utility costs decreased by about 29%. In this particular era, their fixed customer charges were increased by looks like 200%, but again, annually that's a little over $3,000. That's not a lot of money considering what's coming next. Utility cost means, when you bring it all together, they're reducing about 8% and reducing their CO2 emissions by 75%. Why that was such a big deal is because, again, this client purchases offsets. So that was going to cost them, if they went all gas, about $80,000 a year in offsets versus the electric, about $2,000. Now, I know it's kind of difficult having these conversations with clients because oftentimes it can be polarizing, right? People think this is a political thing, but it's really not. Uh, Donald Trump has two resorts that are all electric, one in Florida, one in Hawaii, and Hawaii has the highest energy costs in the country. You think our builder in chief would have these hotels if it didn't make him money? The economics bit bears fruit. So from that, I'm going to kind of take a pause and say if you want to learn more about all of this, my best-selling book can be found there, Understanding the Green Industrial Revolution. That's essentially what we just talked about, right? An organic economic system by people who choose to spend their money and are happy to spend a little bit more on products that they have a shared value system with, right? Think about fair trade coffee. Happy to spend a little bit more for that product. And if our industry can tap into that, it can be honestly revolutionary. Imagine if 1 in 10 people in the world all of a sudden had healthier space to work, more money in their pocket. These businesses were thriving. It would really truly change the global economic order. And if you want to contact me, there's a QR code you can scan. It's got my personal information, email, whatever you want to do. Feel free to reach out. We are rapidly approaching the launch of our accreditation, EcoChef practitioner, for specifically folks like yourself, where you will learn all about this and more. We go very, very in depth about everything, policy, biophilic design principles, everything. So feel free to reach out. I'm happy to share some info on it. And from that, let's open up for some Q&A.
Oh my gosh, I learned so much. That was fantastic, Chris. I have a question right off the bat. I'm
Sure.
curious that many of our attendees are part of the healthcare space. And
Mhm.
so I was really interested in the indoor air quality piece that you were talking about. But I was
Yeah.
also wondering, has anyone done any studies on sort of workplace safety, like burns and injuries reduction due to electrification
That's a great
that you know of?
question. I don't know of that specific angle. I did just complete two studies with NYU and Stanford where we looked at air quality specifically.
Mhm.
The NYU study, the student that we were working with, uh, he's actually going to be looking at biomarkers as well. So that's interesting. I'm excited to see when that comes out. But those are two landmark studies that, first of its kind, no one's really gone in to study the air quality. So I imagine it's probably pretty similar with types of injuries like that. I'm sure probably OSHA did something like that. So I'm excited to see if there is. I love to read that.
Yeah, that'd
But
be really
I will say,
interesting.
I will say that some of the data that we found when studying these kitchens was the air quality was worse than we thought in some places. Like we saw
Mm,
benzene levels. One particular kitchen, we saw benzene levels exceeding the equivalent of a whole carton of cigarettes in 15 minutes.
wow.
So it's pretty bad considering that's why we banned indoor smoking for secondhand smoking because there is no safe levels of benzene. So
And 10%
it's
of our workforce is in this
it,
space.
that's exactly right. Like we're exposing 10% of our population or of our working population to this. There was a conversation around then called the silent worker, which was, people like, it's my choice to smoke if I want to. Well, the silent worker can't. You're
Right.
now removing their agency. And I think a similar conversation is going to come out where we're going to be having a conversation like, what are people being forced to expose themselves to for a paycheck? And
Yeah,
historically, we don't pay very
I
well.
think the injury piece would really be an effective tool for those trying to advocate for this change in their institutions, because
Yeah,
that's like a realized cost. Like that's also a
absolutely.
quantifiable
Yeah.
realized cost and could be quite motivating. Well, we have
We did
questions coming
speak
in.
to one
Okay.
insurance company who was putting together a task force on restaurants. So
Hmm.
I imagine they're going to be looking into that specifically as well.
I hope they do. I look forward to reading about that. So questions are starting to come in. If you have a
Awesome.
question, and you're curious about something, pop it into the Q&A function of the webinar. We'll get started with the questions that we have now, but please feel free to add them as we go. So one of our listeners is interested to know if these same risks might be present for indoor gas fireplaces. Do you have any exposure to that exposure?
Uh, that's a great question. I mean, I imagine that any sort of, if you can smell it, you could probably expect that it's not being captured. Uh, so I imagine that there is some sort of fugitive emissions. I haven't really looked into that, considering not a lot of fireplaces in commercial kitchens, but I would imagine so. I would love to see those numbers. I think that, especially like in our house, we love fireplaces, but they're always all electric. It's just easier that way. Not for any altruistic reasons, just because my wife likes to rearrange the room, and it's nice to not have a fireplace in the dead center of the room. We can put it anywhere that we want, and it's just cheaper that way, right? So
Yeah. Yeah, well, we'll have
Yeah,
to look for the literature and see if
yes.
anybody's done this. I know there's
And
quite
please
a bit
share it.
of research out there, and I'm pretty sure we have one listener on the call who's one of those researchers who works on specifically residential kitchen emissions associated with natural gas stoves. So I think although we may not know that at our fingertips, it might be something that's known out in the marketplace. So another listener is saying we talk about operational savings. So, what is might be a good rule of thumb for the upfront capex cost versus
Hmm.
op cost payoff timeline? Like, is this you mentioned the one case study that you showed, it sort of had a 3 month payback um, on the premium of going all electric, or it was somewhere around there. Can you
It
talk a
was
little more about that?
9 months for the hood ventilation.
Nine
Yeah,
months,
so we're
sorry.
seeing that on average is around 22%, sorry, 22%, 22-month payback. So within 2 years, like 18 to 22 months. So between a year and a half to 2 years, you've recouped those capex costs, which means
Oh,
that
great.
for the remainder of that, we'll call it 20-year kitchen that you designed, that's their savings in perpetuity. That's
Mm,
reinvestment back into your spaces. And if that insurance company comes through with positive findings, they might also now reduce your
yeah,
uh, you know your liability
great.
insurance, but
Yeah.
what your rates. Thank you. So yeah, so there is an increase upfront cost, but it's the back end cost that saves you substantially. And for the some of the case studies that some of the data that I pointed to, one of which was a mixed use building, that type of reporting was really important for the client because they were able to then show their bosses, here's what we're going to be saving as a company, and here's the savings that we can pass on to the tenant to help the tenant then be more comfortable by making this transition. And we're going to be working on another one in San Francisco, which I can't talk about much, but it's going to be a very high profile restaurant.
Nice. So there's a related question here. And when it comes to multifamily and senior housing, have you seen regulations or movement towards induction cooking in those
Oh
hospitality
yeah,
settings?
I would say in the residential market, I think this is one of the few times I've seen that the residential market's going to be influencing the commercial market because they're adopting it at a far quicker pace than you're seeing the commercial market, despite the fact that every international culinary competition in the world is all electric. From the Culinary Olympics to the Bocuse d'Or,
Huh.
it has been for a long time. And it's like that for a couple of reasons. One, it's easier to get energy into a space than it is to get gas. The gas
Sure.
infrastructure is incredibly costly.
Yeah.
There was one architect I spoke with that said if you omit, like for a new build, omit the gas infrastructure from a build, your ROI is near instant. It's that expensive. And also it's more precise, right? So when you go to I'm sure you've all been to a restaurant on a Monday and it's a totally different experience than on a Friday, right? Uh, that inconsistency kills restaurants. The most expensive thing in any restaurant's an empty seat. I don't care what any chef says about their A5 Wagyu. The empty seat is the biggest expense. And if we're inconsistent, people are going to want to come to our establishments. So now I can write recipes that says, "Hey, Christina, I need you to sear off these short ribs at 400 degrees Fahrenheit for 4 minutes on each side and braise it at 185 for 6 hours." That's a level of consistency we never had, right? Because
Mhm.
before it was sear short ribs, braise on medium low for 6 hours. Well, how deep of a sear do you want? When was the last
Mm.
time that stove was serviced? Is it an orange flame, a blue flame? Is it going to go out if someone walks by because it's too low and it's kind of a weak flame? You can under and over braise meats. I have seen people try to do things on the stovetop. Fire goes out, no one notices, it never gets done, and then now they're
Oh,
scrambling for service. Right? Doesn't
sure.
happen with induction. So it's more consistent, and now you have a more precise product, which normally that level of precision isn't found unless you're doing either something in pastry or you're doing something in the very high profile or Michelin star type restaurant. So yeah, precision's key.
We have a question here. I have a client wondering if they can do bar food at an equal level to gas.
Yes,
That make sense
actually,
to you?
those little graphs that you see, or not graphs, those little tables that I had throughout we modeled a wine bar. So
Oh,
we showed that there was significant savings for the client as well as for the tenant. So yeah, you can absolutely do that. The only thing that's going to limit your cuisine is your own imagination. Uh, there's nothing you can't create on gas equipment that you can't recreate on induction or electric. And I'm happy to
interesting.
talk to your client and help get them to understand it from a chef's perspective. Oftentimes, these clients say, "Yeah, you're not a chef. You don't know what you're talking about. You're just a designer, and you can't
That's
tell me
true.
what's right for my space." So having someone who's been, wears the chef whites, they go, "Okay, I get it." And it has a little bit of
Credibility.
credibility
You have
there.
instant credibility.
Yeah.
That's wonderful.
So feel free to reach out.
All right. Can you speak to the use of type 2 hoods as a net zero strategy? We feel this limits the type of equipment that can be used and ties the chef's hands. However, we've heard this is a strategy employed in some parts of the country.
Uh, I haven't seen it used for like induction. I mean, you can get around it. Um, I would say maybe strategic use of ventless hoods. We worked on a passive house project where we were able to cut the hood ventilation in half,
Mm,
and by strategically using ventless equipment.
interesting.
So I haven't come across that personally, but I'd be interested in learning more about it.
Great. Here's another one. What are some of the savings that you're seeing in the reduction of tempering spaces on the CapEx side? When designing, we want to propose this as a solution. Then we want to approach the HVAC savings as well. Just wondering if you've explored construction cost differences outside of the kitchen equipment itself for savings totals.
Right. So that's something that we want to get into. I'm hoping that as we work more with Mazzetti, we'll be able to quantify that and model that because, yeah, there could be substantial savings there, right? Because if you're
Hmm.
going from a 130-degree kitchen to a 70-degree kitchen, that means you need less air conditioning. Also, we
Yeah.
can reduce the amount of HVAC needs for the hood ventilation and shrink
Mhm.
the hood. We can, your refrigeration is going to cycle on and off less often. So, like, there's a lot of savings there that needs to be quantified. I'm not an engineer, but I love to talk to those of you who are,
We can
and
help with
see
that.
if, yeah, and then let's see if we can put something together to show because we were able to look at the equipment, no problem. But when it comes to ventilation, that's a whole other mess that I just am not educated for. But yeah, there could be substantial savings. Just like we showed at the Chatham project, they were saving about $100,000 a quarter. That's pretty nuts.
Yeah, that's pretty impressive.
That is an extreme case, by the way, because they have geothermals. They went the whole nine
Yeah,
yards. But
total
that's a
integration.
savings that could be realized if they went all in.
All right, here's another one. Reducing exhaust air requirements for all electric cooking um, is a concern from a code perspective. NFPA and ASHRAE standard do not provide for a lower exhaust value based on combustible versus electric fuel sources. Are you aware of any potential changes afoot in this area that
Right.
might
So those
allow
so
us
those
to make
codes,
those
yeah,
changes?
yeah. So like that, the ventilation, like that's why we like to go with demand control because it can kind of work based on what the usage is without truly shrinking the amount of needs. Because like yeah, though you are governed by those codes. Um, Again, getting around that is also using strategic ventless equipment to shrink the hood size in a way that's going to be compliant with code. So I'm not aware of them. We've had tentative conversation with some folks who work on reach codes, but I'm not aware of them implementing them just yet. But they're looking into it. Some of the folks that we've talked to in, say, San Francisco have been looking into studying that so they can kind of update their codes. So, is it going to happen right away? I hope so, but government is not known for being fast.
Yes, those code processes are long cycles. All
Right.
right, here's another one. This is actually a question that I have because I've run up against this as I've tried to propose this with clients. Do you have any strategies around changing chef culture that will only give up their gas over their dead body?
I've heard that so much. Yes. Matter of fact, and we talked a little bit about this before the call, but we've been kind of building out a holistic approach to how we're to how we're going to be tackling this, right? The first is education and certification. So with EcoChef, what that is a kitchen certification. Think of it like LEED, but for kitchens, right? With a kitchen rating system, we've standardized how to design, build, and operate these kitchens based on verifiable standards. We've also, you know, going to be certifying kitchens from bronze all the way to platinum. We're also partnered with Well, so we are an approved program with Well, and my partner and I sits on their thermal advisory comfort board. So like we are already working with some of the players, and we're just launching. Additionally, we have a home certification. We certified two homes in Atlanta to show that uh, the it was a little bit odd to the developer to say, why should we EcoChef certify a whole home? And the conversation was, people don't care how you heat your water, people don't care how you heat your home, they care about how they cook. So if you have an all electric kitchen, that can be a sticking point, especially in Atlanta. In Georgia, they're going to want gas, right? So now you have a kitchen that is designed and built by chefs. They go, oh, I want that. So we have a couple of homes, and it sold almost immediately. So we're showing that there's a market there, and hopefully we'll be able to do the same for mixed use residential projects. Professional accreditations. We have three levels that we're launching: associate, culinarian, and practitioner. A practitioner, we're actually open for applications for cohort one that we're going to be launching in the spring. So anyone interested, please send me an email. But we right now partner with the American Culinary Federation on the culinarian EcoChef culinarian accreditation (ECC). We've had a number of interest from people who have gone through the program, who've, from large companies like an Airmark to small independent restaurants. We just had that particular course approved for a university in Barbados. So they're going to be working with their tourism board to get chefs going through there in the off season to get them educated. So we have a full curriculum around there with an accreditation. Uh, we're also going to be launching equipment standards and certification, so that way it's easier for you to make recommendations on equipment if it's certified. To say, hey, this is chef certified equipment for, so it's going to work just fine. Again, helps with that conversation. We're also again partnering on research studies with PSE and Stanford, with NYU, and creating incentive programs like we did with the Pennsylvania Department of Environmental Protection. And finally, we're working with industry partners like the American Culinary Federation, the Chaîne Rôtisseurs, which is the oldest gastronomic society in the world, as well as their 501c3, the Académie de Brillante de Sèvres, which handles all of their competitions, things like that for the young chefs, as well as the American Academy of Hospitality Sciences, which has the Star Diamond Award, which works with the ultra luxury. Because let's be honest, got it. That actually trickles down. Technology trickles down. So we have this holistic approach where we're trying to move those who are coming into the workforce, those who are already in the workforce, with manufacturers, with designers, with industry organizations. I actually, before getting on this call, just got off a call with the Sustainability Council for the World Association of Chefs Society. So we're working every angle we can to get this industry moving in that direction.
Well, thank you for that. That's an important piece of this puzzle.
Yeah, for sure.
One last question in our last couple of minutes that we have. There are so many great questions here. I am so sorry we won't be able to get to all of them. But before I ask it, I'll just share with the audience that what we will do is answer the questions we didn't get to in writing, and share that when we share the recording and the slides from today. So don't worry, you'll all get the answer to these great questions. So just one last piece about sort of cooking quality. Um, is cooking with electric induction sort of the same as cooking with gas stoves in terms of heat flow, transfer uniformity over the cooking pots? Certain ethnic foods, such as high temperature cooking, may need heat transfer uniformly across cooking pans and pots. And you mentioned that a little bit in your presentation, but
Yeah,
maybe just a little more about sort of
sure.
from the chef's perspective. How does it
Yeah.
compare?
Uh, there's there's kind of two ways I can answer this. I would say first and foremost, it really can't compare. It's so much more powerful. The heat transfer is very even, right? You don't have hot and cold spots like you do with gas. Because I've worked in burners where only half of it's working, the other half isn't, right? So It happens. Happens quite often, actually. Also, high heat, like for example, woks. Woks need to be very hot, right? Wok loosely translates to the breath of the wok. It's incorrectly assumed that it means the as you're tossing it, the aerosolized fats are being, burned off and then falling onto the food. And that's just not this Brazilian guy telling you. That's what Martin Yan, which I would consider the godfather of Asian cuisine in the United States, um, said. So, and he prefers cooking on induction woks. He's done demonstrations on both TV and actually at the ACF convention not more than once. Uh, he prefers it that way, and we've had conversations with people in Hong Kong, not just designers but also chefs and manufacturers. This is something that's happening more and more. When I was talking to Chef Yang, he said that most restaurants in Hong Kong are opening electric because it just works that way. Um, I haven't been there. Maybe someone wants to send me out there to verify myself. I would love to do that. But yeah, I mean, there are some things that probably isn't going to work, right? If you're uh, doing, I don't know, using the Beachaton coals, I say cook that way. You're not a bad person for cooking that way. Go for it. Like if you're dead set, like, hey, I want to cook over coals, and this is just the way I like to do it. That's totally fine. I'm just saying we don't need every person in the world cooking this way. We don't need every person in America cooking with gas. We don't need every chef in America cooking with gas. And who's to say you don't just have a kitchen that's all electric? But if you really want this one thing, it's like, for example, Bonefish Grill. They're very famous for cooking on wood grills.
Hmm.
They use actual wood. They don't use gas for their grills. Everything else is gas. Hey, that's fine. That's your shtick. Go for it. There's just a better way of doing the rest of it.
Well, I am so appreciative for this morning's conversation, and we received several nice notes in the Q&A
Oh,
that
thank you,
people
everybody.
enjoyed it. So for all of you who have attended, thank you for the great questions. As I mentioned, we'll follow up on those questions in writing when we follow up with you with the materials. And I want to thank Chris. This was wonderful and just what I hoped we would be able to talk about today. So thank you. I would remind everyone that we do this series every third Tuesday of the month. You can keep track of what we're offering when by following us on LinkedIn, on Mazzetti, following Mazzetti, or following me on LinkedIn. I always try to make sure that people are informed about what's coming next. So next month, we're very excited to be hosting Williams College. Tanya is the director for sustainability at Williams College, a former colleague of mine. And she's going to be talking about embedding sustainability into your capital planning process and how to ensure that those aspirational climate plans turn into action on the ground. So I think it's going to be really interesting. It's a higher ed example, but I think it applies to any campus type environment where complex decisions are being made, and you need to learn how to influence those decisions. So thank you again for your time this morning. As a reminder, this and past sessions are available on our website, mazzetti.com, under resources. And you're welcome to spread the word. These are available to anyone who's interested in attending. All right. With that, we'll say goodbye and see you soon.